thought I will make a video. First, we have to find probabilities in our worldview. We have to find probabilities in probabilities. Probabilities. Probabilities are so important because probabilities is probability, and probability is the way how we find measurement of probability. And when we find probabilities, we have to find probabilities and probabilities to find probabilities of probabilities and probabilities and probabilities. And this is nonsense. What I want to talk about today is mathematics. And mathematics is more than probability. Probability is important, but we have to find mathematics in doing mathematics. Mathematics is a way how to handle uncertainty. Uncertainty is part of probability. And Claire, 2x squared plus x minus 15 divided by x plus 3. What can you do? You can use a binom and the x squared to 2 you have to subtract the x plus 3 x plus 3. How do you do that? You don't use a binom. What do you do? I think you use a binom. Look which binom. Binom. Binomial formats. I have an idea. Can you teach mathematics by talking about mathematics? Is this a new way of teaching mathematics? Have you thought about that? You have your thought process, thinking about mathematics, how someone thinks about mathematics, teaches you on a psychological level mathematics. Then you can listen to somebody who talks about mathematics and you can find patterns in the language. This is maybe the correct psychological way how to teach mathematics. Other than that, you have to find each learning mathematics is hard, and when you consider that mathematics is hard, why it's hard? Because you don't know. And how do you know? You need to teach each formula or each event that is happening in your approach of doing mathematics to apply it. Hence, we have to accept each thought process that is happening in your mind to understand mathematics. Each event that is happening has to be documented, and then you can process the information, find patterns, As you can read articles, you can apply your new way of thinking, and that is mathematics in your approach of doing mathematics. Doing mathematics is approaching, you approach patterns, hence language are patterns. You can create patterns through accepting language in your life, and you can teach mathematics with language. Hence you can teach mathematics in a language way. Hence I can talk in videos about doing mathematics, how I approach it, and I can, instead of writing mathematics, I can do mathematics in videos. And then I don't know the answers, and I'm not a teacher. And when we consider that, then we have to understand that I'm not a teacher and I don't want to teach mathematics. I maybe want to make mathematical videos, but then doing mathematics is different, and it takes the approach of books. Books are important, and we have to learn mathematics through books, not through videos. Videos are important to follow the steps, but when we consider that doing mathematics is an approach of discontinuous progress. We make progress over time, hence we learning comes in a nonlinear fashion. It's created in steps, or in maybe in nonlinear, multi-nonlinear ways. Hence, we build our understanding of mathematics through multiple steps of nonlinear thinking. Nonlinear acceptance of nonlinearity is how we handle the probability of becoming better in mathematics. Hence, we create our understanding through randomness, and not through randomness. We can accept we can do probability, and we can become better in mathematics by doing probability and by probabilistic thinking. Probabilistic thinking teaches us that we can become better in mathematics, and that we can apply mathematics for doing handle the uncertainty of what's important, and how we have to handle mathematics. Mathematics is important for our understanding. It teaches us how to think effectively, and it cleans your it mathematical thinking is clean thinking. It is about neglecting information that are less important and becoming clean in your thinking. Psychology, on the other hand, is a way how to handle talk. You become both have to do with pattern recognition and uncertain information. Pattern recognition is important for psychology. We accept the science of psychology is the science of pattern recognition, such as mathematics is. Mathematics is a way how to handle uncertainty, and we both handle uncertainty and we have to deal with uncertainty. Psychology is uncertainty applied, and it both is about pattern recognition. Ah, hence, we need intelligence. Concluding things is important for what? Binomial theorem. Binomial coefficient. Words are necessary for finding probabilities. We find probabilities in language. Speaking is important for making progress, and social psychology and phenomena of social phenomena are important for changes in our way of thinking. We can teach mathematics by doing psychology, but then we can do mathematics by book learning. Book learning is thinking, thinking applied. What we think are, we can write down what we think. Hence, we can teach thinking by reading books. Books are important for teach thinking. Teach thinking. Creativity can occur. Creative thought can occur when something when somebody doesn't read. Creative thoughts are not what we have found is that what I have found is that creative thoughts are important, but we have our understanding, and the understanding is recreated through creative thought. Creative thought is important for developing new fields or creating new innovations. New innovations create something that is okay. Claire, I'm silent. No measure formel here. A plus B Quadrat. Das ist keine binomische Formel. What I learned today, you have to put effort in doing mathematics. If you don't put the effort in, hence you don't learn how to learn mathematics. Learning mathematics takes time, and it takes time to find out how to learn. And you have to find out how to learn, and then you have to apply it. You have to put the effort in, and this there is energy involved in